Good evening, all of you. Good morning, good evening, and hopefully all of you are very fine and doing well. Please give me 1 minute.
Rain, how we drop? We say no any rain. Rain. Why God? You God. You don't want to bring rain.
All of you, please keep mute. And today in this session, we will discuss about the symbolic mathematics. To use MATLAB in your mathematics, for numerical mathematics, for automation techniques, ODE, mathematical modeling, and for various numerical methods. Then there was today's session on intelligent techniques. So artificial neural network is there, and if you are interested to implement in a different type of prompts mathematics, then the most important thing is to understand symbolic mathematics and how we can solve different type of problems by using MATLAB. And the most important thing is syntax of the mathematics in MATLAB. How we can build a problem, how we can create function. Many things are there. This is just one type of introductory about symbolic mathematics, what is symbolic mathematics tool, and how we can use. So welcome in this session, all of you, and all the participants who are attending this session on live streaming. There are many participants who are joining and will join on the live streaming link. Okay, so now we are going to start, and welcome all of you. You can raise your hand whenever you have any question, but now I would like to mute all of you because sometimes unmuted automatically, then there is some problem. So whenever you have any kind of question, you can raise your hand. Okay. So just 1 minute, I would like to share my screen with you, and then we start one by one all these things. So all of you are muted, and only I will ask in between whenever it is required, or you can raise your hand. Okay. So I have one is this PDF file, and other is I have MATLAB window. You can see. So when you will open MATLAB, and you can find easily symbolic math toolbox. Okay, we are going to talking about this one. So first thing is why symbolic math toolbox is required. So whenever we simplify any kind of function or differential equation or system of equations, system of differential equations, partial differential equation, integration. So this type of problems are in the form of can be deal with the symbolic math toolbox. So symbolic math toolbox lets you analytically perform differentiation, integration, simplification, all type of transforms like Laplace transform, Fourier transform, Hankel transform is there, and solving equations. You can also perform dimensional computation and conversions using US unit system. Your computation can be performed either analytically or using variable precision arithmetic with the result displayed in mathematical typeset. So whenever you go to this symbolic computation in MATLAB, okay, and also I will provide all these content are available in a PDF file. You can see I have this is a PDF file. Okay, so this is a symbolic toolbox, and in which you can you can easily solve different type of problems like equations, linear algebra, variable arithmetic and simplifications, substitutions, calculus. Okay, so just 1 minute in the beginning. Yes, this is the this is the symbolic toolbox. This file I will provide you at the end. I let you know where you can find this file easily. Okay. So these are the various topics are there. Introduction about symbolic object, then how we can create a symbolic variable, substitution of a symbolic variable, symbolic and numeric conversions. All these things are very important to work on mathematics with the help of MATLAB. Okay, then by using these different type of symbolic variable, we will deal with the different type of topic like calculus, differentiation, integration, Taylor series, all type of work associated with the mathematics we can do easily. But before all these things, we must be familiar with the symbolic. So all these topic we can easily deal with mathematics in MATLAB. Okay. Algebra solving equations, integral transform, like you can see special function applied to mathematics. Then we have generating code for the symbolic that will be MUPAD is also another tool we can directly use, but all the things I will not be able to cover, but just I will let you know about overview and how we can use, and it will take more time to use cover all these topics. So we start one by one. Uh, so these are the main inbuilt functions which we cover, like a calculus, linear algebra, simplifications, solution of equations, special mathematical function, variables, and many more. Okay, so now just come here. What is symbolic object? This is very important, and which type of function can be used. So when symbolic method toolbox software always uses symbolic object to represent symbolic variables, expressions, and matrices. The actual computation involving symbolic object are performed by using MUPAD, a symbolic math engine. You can see on the MATLAB. I will show you later. So you can see if we enter SQRT, see in the MATLAB first. So there is a help function, and when you will enter ELFUN. So by using this command, all the mathematical functions, inbuilt functions are available, and this will return us the list of all the functions. Okay. When you will enter, you can see it is opening. You can see the list of basic elementary functions is there. Okay, in the beginning you can see trigonometric functions are there, hyperbolic sine, inverse, all the trigonometric functions are available in this. Then we have exponentials. Okay, and then we have complex angle, absolute values, how we can phase angle and construct complex data, MSC part, real part, etc. Okay. Then after we have ring and remainder, all the functions are available. And also the most important thing is sets of mathematics in MATLAB. So the most important thing is to understand the syntax. Okay, so these are the input functions, but you need to apply all these things. So what you will do? I am choosing one function, say sine, first one, very first function, sine. So when you will click on it, this will open. When you will click on it, this will open. See, the sine function has been opened and we have this information. So if you are using this sine, so the argument will be radian. Okay. So this will the sine element of x we can use in this. See here, 90, 90, and that this is, but it is 0.8940. Okay, and if you will enter this function sine d, you can see sine d at this place. Yeah, you can see more detail about this. This will the sign of the argument is in degrees. See now sine d and enter here 90, and you can see that this is now equal to 1. So the examples are available for elementary functions, and you can easily extract from the window. And there is very simple function, which function is EL elementary and FUN function, and this will return the complete list of functions in the MATLAB, and you need to use anywhere in your work. You can find out more detail and how you can use all the things are available. You can see one more, like you want to use complex variable. If you have complex variable that you want to use, see, we will click on it. Okay, so you can see how you can write a complex number or uh, variable. Complex variable contain two parts, one is real and other is imaginary. Okay, see. Okay, so at this place you can find more detail about this, and various examples you can find out also, and you can go to the document for complex. Okay, and other functions named complex. All the things are available here there. Also, I and J both are used for iota. Okay, so this is just an overview about the elementary functions C and C. Now the problem is that I have a polynomial. Suppose that I have a polynomial px is equal to, I have a polynomial x square plus 2x plus 3. Okay, this is a polynomial, and when you will enter, see the problem. This is the running value. Okay, I have choose only symbolic variable, just CLC and 3. Okay, and CLC. Now see the statement. When I enter here this statement, and it says it unrecognized function or variable. Okay, so you want to manipulate this polynomial, but you are not able to manipulate this type of equations. So the same way we have a system of equations, we have polynomials, we have differential equations, we have different type of functions. So all these can easily first we have to declare equal to zeta. Okay, see the same. I'm using here same function. This same x. Okay, and 1 minute. Please. Okay, my audio is fine. Hello. My audio is fine. Just 1 minute. Someone is asking audio is not fine. Please let me know. My audio is fine. I am audible. Still my voice is breaking. It may be from your side because at my side all the things are very fine. Okay. So now
From
I
my
am
side,
sharing my
the voice
desktop.
is breaking. From my side,
Yeah, it
the
may
voice
be.
is broken.
Okay. Now it is fine.
Yes, much better now.
Okay. Now Naveen Kumar, I am audible.
Yes, you're audible
Naveen.
from my side.
Okay. 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 Thank you. So so now I have to use this function. This is the sim function. Now we can easily manipulate the above equation, and when you will enter, now we can manipulate this. Okay. See, I want to pass the value 5 and enter. Now we can easily manipulate this equation. We can find out the root of equation. We can simplify. So this is the main use of this symbolic variable and numbers. Okay, we can use in very different ways. So now you can see if if we are using this simple function square root, okay, then this will return the value 1.4142. Okay, and if you are using symbolic function, if you are using the symbolic function, and when you will use this statement in command window, see what happens. To clear the command window and see we use and you are using like in this way. See, this is very simple. So this is the main difference between these two. In the case of symbolic, then it will return in this form. And when you are not using, then this will be written in this form. So these are the symbolic numbers. Okay. And when we are dealing with the different type of variables, then we have to define symbolic variable, and then after we can manipulate for different type of problems. You can see creating symbolic variable. How we can create? We can create like by using in this way. Okay. Uh, if you are using, you want to declare one variable, sometimes we have to declare in the programming. Okay, you can declare variable in the x is equal to symbolic variable and you can declare in this way. Suppose I want to declare for y, okay. I am using here y because x already I have declared. And when I will enter, now I can manipulate it anywhere. Like I have a is equal to, I am writing a is equal to, this is a y function, sine y function, okay. And when you will enter, you can see that we can manipulate. And if you want to differentiate DIFF is a function to differentiate any function. Now I am going to differentiate a. A is equal to sine y. See, when you will use this function, this will differentiate a is equal to sine y. You can see the derivative of a is cosine y. Okay, so in this way, you can, by using declaring the symbolic variable, you can use for different type of prompts in mathematics. Okay, CLC, this will clear the command window, and clear, this will delete all the variables which will be in the workspace. You can see on the right hand side, this is the workspace, and there are some x variable a and etc. So when we will use this statement, this will clear the workspace. Now you can see, now you can see, uh, we have, we are using here rho is equal to, we have 1 plus root 5 upon 2, and we want to represent in symbolic form. Okay, so we will use for this as a symbolic, like in this way. So same is equal
Many are
to
those
1
mathematics
1 plus,
reasoning. Asa whether she can
pardon.
asa whether she can do it. Even yourself, those things are not difficult. Don't send them. I solve it. You can say use it. You can reason more than Chioma. You can explain to her. But some my example on how I used to write them a mail. Anybody can read it. Not only her.
Yes, yes, there I will present, there is some more examples also. Please just follow this, okay. I will present more examples. If you are using to for this equation, like C at this place, we have f is equal to ax square plus bx plus c. And if you are using symbolic in this way, then this will not work. Okay, because there are a, b, and c, three parameters are there, and x is variable. So for that, we have to symbolize a, b, and c only then. First see this, first see this function, okay, from use in MATLAB, use in MATLAB, and see when we will enter, this return the error. Why? Because there is a, b, and c. We need to declare all these first. Okay, so there are two different ways. Either you can declare like in this way, a is a symbolic variable, then b is a symbolic variable, c is a symbolic variable, x is a symbolic variable. Or the other way, we can directly declare all these with this statement. Okay, see, I am using only this statement, and in the single statement we can declare all the variables and parameters which are involving. So now you can see that A, B, C, and X appeared on the workspace. Yeah, you can see. And all these are the symbolic variables. Their size you can see. Okay. Now you can enter the this function. And when you will enter, sorry, f is equal to, just 1 minute. Sim, it will appear now. Okay, and then use at this place. Why? Since convenient character vector and the string on the first can only be specify a variable. Okay. Uh, leave it, leave it. On just 1 minute. Sim function. Then this one. X square plus bx plus c. These are the symbolic A, B, C, and we are using here. It must be correct. Why there is wrong? It's A, B, C, and X. Okay, and then first we will see data. Okay. Now, if you want to like simple variables, simply uses every, then you can manipulate is variable addition, subtraction, multiplication, and many more. Okay. Now there is find sim command. Okay, and by using the find sim command, if we are using multiple variables are symbolic variables are there, and we can find the symbolic variable involving one particular function. See, we are using here. There are two functions. One is and is the symbolic variable. At one time, you can declare many variable or parameters. Okay, depends upon in which function, which variable you are using. So you can see I have two functions. One is f, which is equal to x raised to power n, and second is g function. Okay, and when you will enter, and now you can use find function. You can use find sim variable function, and when you will use this statement, and you can see that when you will enter, MATLAB got busy because uh, there are three things are parallel working. One is streaming, other is Toolbox, and the third is MATLAB itself. So all the things becomes very heavy when we are using parallel. Okay, so this will return the value. MATLAB. Find sim command. Okay, and when we are using, why this is the problem? Okay, so uh, actually the version is this file which I was using. That was the version, and then I'm using MATLAB Windows 2021. So I think there is some little bit syntax difference. That's why the problem is occurring. Now this is the, I think it will be very fine. So now you can see we are using symbolic variable x, and we have a function. We have a function. Okay, CLC, and clear all this. Okay. So now you can see we are using a symbolic one variable, and there is a function. We can pass the value in many different ways. One is this way. Suppose this is 2, and we will enter. Yes. See once again. Yeah. If you are using like in this way, here is x. Okay, and enter. As I have shown in the previous system. Now you can pass the value in this way. Pass the value 2, and this will return the value. But there is a sub function. There is sub command. Okay. This sub command, or you can say also these are the function. So this function is very helpful to manipulate our different type of functions, and you can see that this function was used, and can directly manipulate and easy to use, and we can pass the value. You can see we okay. Yes. So now there is a sub function, and you can see that if we have any statement in this way, we can easily manipulate this type of function for passing the value by using subs function. Okay. See, I have this function, and we are using in the MATLAB. At the bottom you can see, and now by using sub function, we are passing the value x equal to 2 in the function. Okay, and by using sub function you can easily pass the value for x variable, and this is the returning value. So this is the very simple use for this sub function, and you can see more examples also. In this place you can see we have two different variables. One is x and other is y. Okay, so if you want to pass the value for only x variable, you can use this sub function, and when you will use this function, the value for x equal to 3 will be passed for this function. You can see using this function, I am copying and this statement because time. Okay, so we have x and y two variable has been declared, and f is a function involving two variables, and when you will enter, we have this function, and we want to pass the value for subs function. This is the subs function, and f x equal to 3. We have x, and the value for x variable we have is 3. And when you will enter, see, in the above equation where we have x, the x value has been passed from this function, and also there is a y variable, and y will be same. If you want to pass the value y equal to 3 for this function, you can easily pass by using the same. Here you can change y variable x into y, and when you enter, you can see now in the this function we have passed the value y is equal to 3, and after that we get this value. Okay, by default, if you are not are using like in this way, sorry, this is the sub function subs, and if you are not assigning uh, any variable, so by default, see what happens. By default, it will choose only x variable. Okay, there are two variable, one is x and other is y. So x is first variable. So by default, it will choose x. Okay. So at this place, we did not assign the value for which variable is 3. So by default, it will choose the first one. The first variable we declare here is x, and then we have y. So by this way, we can pass any value for anyone. Okay. So now you can see. Now you can see some more examples. Someone, please. Again, see again, if you have this matrix, this is by default numeric matrix, and we can convert it into symbolic, and it is very quite simple. This is Hilbert and Hilbert matrix, and it will return the matrix like in this way. Okay, CLC and clear C. This is a matrix, and when you will use symbolic sim function, okay, and pass through this function, okay, see what happened. So this matrix now is in symbolic form. Now this is in symbolic form, so easy to use. Okay, and just you practice on it, and once you will be use all these, it is very simple. So similarly, you can construct a complex variable, like you can declare x one real variable, and y is also a real symbolic variable, or other way you can write in this way, since x y real, okay, x and y both are real variable, and by using this statement, this will return us complex variable. Okay, by using this one, these two statement, we can easily write complex variable. See in the command window here, see. So now this is complex variable. Okay, if you have x is equal to, you are choosing 3, and y is equal to, you have 5. Okay, and enter, then z equal to, see what happened. These we can pass through the function. We have to write the function, and then after we can pass these values. Okay, then we can pass in the function. So now you can see here is f is equal to this function, and a symbolic function is there, and this is strictly non-negative, and z is a complex variable, and we can manipulate by using conjugate of x, conjugate of z, and expand z, and many more. So this will return in this way. Now, we can easily create a symbolic function by using this statement. This will be easy to use a symbolic function. Okay. Now, come in the MATLAB. See these are the syntax by using symbolic variable, and there are various topics like differential equations, limit, integration, calculus is there. We can easily do by using in this way. So there are various syntax are available in the MATLAB, and so these are symbolic very simple example. Uh, uh, and to uh, for this one x approaches to 0. Okay, so in this function we have only x variable, so you can declare only symbolic variable x. Okay, CLC and clear, and again CLC. Now sims x. Okay, and f equal to, we have sine x upon x function, sine x upon x, and by using semicolon the statement will be suppressed. And now if you want to take the limit, you need to take the limit as x approaches to 0. Just you need to use this limit function. Okay, so when we will use this limit function and see, it will return the answer. Okay, so you can see the answer is equal to 1. So for all type of limit we can easily manipulate by using symbolic variable. There are so many examples, various examples are there, and sometimes you want to calculate the limit for this function. You can see x and h are involving for this one. Okay, and we want to choose the limit for h approach to 0. Okay, so we need to declare h as a symbolic variable again, and then you can use this one. So first you need to see that uh, how many symbolic variables are there. So all the symbolic variables which are involving in the function, first we need to declare, and then we can easily manipulate for the same. So now we have to declare both the symbolic variable x and h both. Okay, and in the statement we have, you can see f is a function which is equal to, you can see, sine x plus h minus sine x upon h. Okay, and we need to take here limit for h approaches to 0. Limit is h approaches to 0 for what? F function. And when you will enter, say we have cosine x. So this is the formula for derivative of sine function. Okay, and either by definition you can use, or we can directly take the derivative. So you can see we have the returning value. Very simple to use, just need to understand syntax in the MATLAB for mathematics. Okay, and once you will be able to use, then you will enjoy all these things. Very simple. So you can see that here various examples are there for limit. If you want to take right limit, then we have left limit. So all the things are available, and various examples are there. Okay, and you can easily use all these. Then we have C mathematics. Okay, see here mathematics, solve algebraic equations. we can easily solve algebraic equations. You can see we have this is an one algebraic equation, and for equation you have to use this double equal operator, okay, for specify the familiar quadratic equation. Okay, so keep in mind the equal, if we are using a single equal, then this will be used for assignment, and if you want to use for equal, then we have to use double equal sign. Okay, so this is the main difference. So you can see we want to solve this equation. Okay, we want to solve this equation. So this is the equation. The equation is ax square plus bx plus c is equal to 0. This is the quadratic equation, and abc are symbolic variable parameters, and x is variable. Okay, and when you will enter, we are using here semicolon. This will suppress the statement. Okay, and when you will use this solve function, we are using here solve function. See, so this is the solve function, and function is equation, and we want to solve this equation for x variable. Okay, see this statement very carefully. This thing is important. We are using solve function. This will solve the above equation, and equation we assigned with eqn. Okay, and this equation involve a is there, b is there, c is there, x is there. All the things are variable. Okay, because we have declared at this place a, b, c, x are symbolic variable, but we want to solve this equation for x variable. So we have to write at this place x. And when you will enter, you can see we have two roots are there in the symbolic form. Okay, one is minus b plus b square minus 4ac square root upon 2a. And this is the second root, minus b square minus 4ac, uh, its power 1 by 2 means square root upon 2a. So both the root, the quality question have two root, and both the roots are appeared at its place for symbolic equation. Okay, so this is the importance of the symbolic variable, and we need to declare first, and only then we can use for our, just 1 minute, I have to mute perfectly. Okay, then share the screen. Okay, so in this way we can solve different type of problems by using this first declaring the variable and then using the solve function. Okay, here you can see also there is another way. There is one more way to solve this type of a problem. I am copying this statement from this place, and you can use copy and paste here. You can use directly space. Single statement you can find out the equation of this solution. Uh, so here you can see we have a function. Sometimes we have function, okay, and we can use it to plot it. You can use. We have plot both sides of the equations. We have cosine x is equal to minus sin x. We have the equation cosine x is equal to minus sin x, and we want to plot both sides. cosine and also for the minus sin x. We can easily plot both sides left as well as right by using f plot function. See, we are using here plot function and then on and grid on, and we have two functions and we want to use at the same time for same symbolic variable, then we have to use hold on function. Okay, so we are will plot cosine function, then we are using hold on function, grid on, grids will be appeared in our graph, then f plot will plot the second function, right hand side. Right hand side is minus sin x. Then we title, we are inserting a title for the, and we can declare here legends. These are the is. Uh, so when you will use this statement, when you will use this sequence of statement, okay, and see in the code, CLC, and you can see the corresponding code appeared. We are using it on, so you can see there are some horizontal and vertical lines, and one graph, this is the legend, you can see this is the legend, this small box. Okay, so a red line shows minus sin x graph and blue line shows graph for cosine function. So both the graphs you can see are appeared in this figure. Okay, so I need to cancel. All the things are very simple to use. Just understand the syntax which we are using in MATLAB. Okay, then we have we want to solve some more examples like the ODE, integration and differentiations. Okay, type here calculus, calculus. One minute. It is still opening. Yes. See some examples related to differentiation, integration, and solutions for differential equation. Very quite simple. You can see I present for you. Okay. Yes. There is some pretty function. Okay. Maximum and minimum value. Okay. Finding the input. Is input. So you can see, you can write this type of functions very easily. So this function is involving one variable. So syntax, numerator, this is the numerator, which is 3x squared plus 6x minus 1. This is denominator. So f will be equal to numerator on denominator. And when you will enter, this will appear in the MATLAB like in this way. Okay, and EZ plot is very simple function. You can see using all these statements in the MATLAB. See in the MATLAB. This is the f function, and EZ plot is very simple function. EZ plot is very simple function to use for f. Okay. See here EZ plot. So This is very simple function to program function. We are not needed to require any input variable or dimensions or range for X variable. Just to use is input and it will return a graph for the f function you can see. We didn't assign any value for X variable. Okay. No line is there and it will very simple. It is very simple to use. Toolbox, mathematics. Linear algebra, polynomials, mathematical function. Okay, you can see there at this place various functions are there in mathematics toolbox. Equations. Then we have calculus. In the calculus we have integration. Limit part is there. Partial derivative is there. Transforms. Okay, many things are there. Okay, so for differentiation, we can deal all these one by one. Very simple to use. See the syntax. Okay, see the syntax for differentiation. So at this place you can see sims x variable we defined here. Then we have a function and di double f. This is the function to differentiate f function. So for partial derivative, there is no different variable, different function defined. Only we always use di double f for partial or ODE. Okay. I let you know how you can use all these. So see in the MATLAB, we are using here this one, and then we will use here diff function. Okay. This will differentiate. This will differentiate the function. Okay. And also, if you have a function of two variable, like first we have to declare both the variables, since we are using x and y, and we have a function f is equal to suppose we have this is sine x square plus y square. Okay, and now we want to differentiate with respect to x or with respect to y. So how it can be possible? Di double f and then type here f comma x. Okay, and when you will enter C, so this will return the partial derivative of above function with respect to x. Okay, and if you want to differentiate with respect to y, very simple, di double f and here f comma y. This will differentiate f function with respect to y. Okay, you can see. Sometimes we need a second order. If you want to differentiate second order with respect to x, okay, this is very second order with y, then uh, there are different ways you can use I double f. Okay, then we have di double f. First, we are differentiating f with respect to x. Okay, and then again with respect to x. So this will return partial derivative f function of second order. See, this is the second order partial derivative. If you need mixed derivative, first x then y, then you can use like in this way. I am changing here y. So in the middle term at this place, this is the partial derivative of f with respect to x. Then it will take the partial derivative with respect to y. Okay, and this will return the mixed derivative with respect to x and with respect to y. See, so this is the mixed derivative you can use in this way. There is another way for any order. Sometimes we need higher order. Okay, we need higher order derivative, and you can use by in this way. DIFG2. Okay, we are differentiating G of second order, so this will return the second order derivative. Or this example I use here. And also there is one more interesting example I let you know. Okay. As you have a Bessel function and you want to differentiate all these, you can do. This is the Bessel function. Okay. And this is the B is equal to Bessel J, nu and Z. Both are the symbolic variable, and you can use this statement to differentiate. Okay. Then we need the examples of integration. Yes. This I want to show this function. Yes. So you can use this notation also. Okay. See, I want to differentiate. See. See, I want to differentiate. Just 1 minute. I want to differentiate x function. Sorry. First, see what is f function. This is the f function, and I want to differentiate this function for second order. Okay, this will return the second order partial derivative. And if you need any order, like you want to differentiate with respect to x fifth order, okay, just change this value and enter. Simply you can use for y ODE and PDE, both have same syntax to differentiate. Now I want to present some examples for integration. Then I will present some example how to solve differential equations by using MATLAB. Okay, differential equations with MATLAB. Just 1 minute, I have to check again. MATLAB very heavy. Not responding, no problem. You can see here this file. Just 1 minute. Just 1 minute. We are okay. Solving equations. These are algebraic equations. Okay. But we want to deal with the integral transform. Control F. Integral transform. We want to deal with some examples of differential equation. Just 1 minute. New part. Yes, if you want to integrate These are the notations for integration. Okay. See, yes. If you have any function you want to integrate, then syntax for integration. We have a function int. Int function is used for integration, and in the bracket parenthesis we write here function, and or another way we can write in this way. Sometimes a function is involving two or more than two variables. In that case, we have to define like in this way. Otherwise, we can write it directly in this way. So you can see in the MATLAB, we are using here CLC and clear, then again CLC, symbolic variable. Okay, sims x and y. So you can use like int, and we have sign function, and when you enter, this will return the integration of a sin x. Okay. Sometimes we have a function like this way. F is equal to I have sin x plus y. Okay. Then I have product exponential function x. Okay. Suppose we have this this is a function, and we want to integrate this function with respect to y and with respect to x. Okay, so see, we can do in this way using int function. Then we have f. If you want x, and then enter. So this is the integration with respect to x. So in this different way, we can use easily to find out integration of functions involving one or two variables. Now I would like to present some examples of differential equations. Differential equations, okay. Solve the integration, create symbolic function. Here is solve differential equation using Laplace. Okay. So we can use Laplace transform, but we have some more direct formulas to find out solutions of differential equation. No example. Okay. Just 1 minute, some more examples. We deal with this. So these are different syntax for integration. Or sometimes we have definite integral. Okay, how we can use? So you can see 0 and 5/2 lower and upper limit both are there. You can easily use it in this way. See the syntax. So first we need to integrate. Then we have the function. Then we have the lower limit. Then we have the upper limit. So this syntax we can use for integration. And sometimes if you have a function involving one or two variable, then you can use also this statement in this way. Okay, there are various examples of 2D double integration, triple integration. Okay, many things we can do. So this is introductory lecture, and just to understand we can okay. Texts are available. I will share you. Yes. So integration with complex parameters, you can see this type of problems we can also integrate very easily. And here are the syntax. Okay, same as ax and f is equal to 1 upon a square plus x square. And you can see the lower limit and upper limit integration, then f with x variable, and these are the limit for x variable. All type of integration we can do very easily. Just need to follow the syntax, and various examples for integration are available. This is the series. These are stellar series. Okay, you can also in MATLAB and very familiar. I could not find the example for this differential equation. Just one minute, I able to find out. Okay. Differential equation I want to present for you. Solving equation, then we have integral, then we have okay, solving equation. This is 280. Now you can see here are the examples for differential equation. Okay, just 1 minute. Here we can find the single differential equation. Yes. So for a simple single differential equation, you can see here is the example D-swallow. D-swallow function will be used for differential equation. Okay, so this is very simple differential equation. You can see dy is equal to dy is equal to ty. You can see here the equation. Okay, so this is the syntax to solve this type of problems. So this is dy upon dt is equal to, this is dy upon dt is equal to ty. Okay, and you can use this d-solve function, and when you will enter this statement, this will solve the equation and return the solution for ODE equation. CLC. See, this is a very simple equation. Dy upon dt is equal to ty. Okay, and when you will enter, this is the solution. Okay. So if you have like initial value is there, you can see in the second example, we have this is the initial condition is also there with the differential equation. Y naught is equal to 2, and you can put the boundary conditions along with the differential equation in this way, and you can use, and after that you will see that this constant will not appear because we have the condition, and see this will return the solution of the above equation. Yes, so this equation, after solving this equation, and these are some functions, and we can easily use to solve different type of problems. So you need to start from this place. Very simple examples are there. And after that, you will be able to solve various type of problems. Okay, different examples you can find and their corresponding syntax are available here. And all this you can find in the MATLAB itself. If you have system of equations, you can see at this place you have two equations, and these also can be solved. Okay, so I would like to take now your questions from your side. I will share all this content with you. Just 1 minute. I would like to unmute all of you. Yes, uh, all of you are now unmuted. Uh, if you have any question, please feel free to ask from me. Because this was the just introductory and how we can use symbolic mathematics tool for mathematics. Okay, and it is very useful, very helpful, and the content which are involving in this file are very basic. As you want to start to implement or to use MATLAB for MathBox for then you can start from this place. Just you need to understand the syntax, and once you start to work on it, then you can solve various type of problems, and also you can implement then after to solve different type of to apply numerical methods, approximations. Then there are different type of solvers. Then we can implement artificial neural network to solve different type of problems. Okay, mathematical modeling is there, optimization techniques are there, but the most important thing is to understand the basic concept, and the basic to advanced we can deal all these type of problems. Now I would like questions from your side, if you can, if you want to ask from me. Yes, due to some network issue, I think at many places there are network issue problems. Yes. Uh, Good evening, all of you. Many participants are there who are attending online streaming. Okay, so please let me know if you want to know more thing or you want to ask any question. Very basic content I try to present here. All of you are thinking who will speak first. Okay, I start to ask from Jasprit Kaur. Kavita, Kapil Juneja, Viresh Kumar, Dr. Naveen Kumar. I think you are from Chandigarh University. Yes, please. Any question? Why you are not trying to unmute yourself? Just you are dropping the message. I want to listen from your side. Yes, please.
Yeah, thank you for the presentation. Yeah, it's just like I call it the last portion of your presentation because the internet I didn't see the screen, so there where I really wanted to ask questions, especially when you're on that fluent application. But I did not
Yes,
see the screen, so I really
please.
yeah, because yeah. The network did not allow me to
Yes,
see
we
your
can do
screen
it.
being shared there. But then I will get it from the lecture note. That what I said. Thank you.
Thank you. From other side, please. Okay, now the thing is, I will share the this file in the WhatsApp group, all the WhatsApp group. Okay, and also the participant who are attending this session on the live streaming, they will get from this place. Just I would like to share once again, so that you can find easily. And also I requested to all the participants to submit feedback. Feedback is very important. Okay, I have shared the content with all of you, and where you can get this content, you need to visit at the website YouTube channel, and when you will open, it is opening. Just 1 minute. Yes. So you can very easily search as Math Tech Foundation, and you can easily go to the YouTube channel where all the content are available. Okay, by searching a space, enter the name, then go to playlist. Okay, and all the playlists are available. And this is the very first training workshop on basic computing with MATLAB. Open this playlist. Okay, so when you will open this playlist, okay, yes, I think due to network issue, it is not opening. No problem. I will send this link on your email addresses to each participant. Okay. So some of you are on this meeting and some are live streaming. So who are attending on the live streaming, they will get from their email. Okay. So this was the fourth session. And now I would like to ask if you can suggest me before this session, there was one more session on training workshop, and some were asking to continue on each Sunday. So can you please suggest if you are interested to continue for other topics, we can keep continue so that this may be helpful and fruitful for all of you. And many things we can discuss here depends upon you and from your suggestion. Either you can put you in the chat box. Chat box is there. If someone is not able to speak or unmute, then you can submit in the chat box.